Hello, good day viewers, and you're welcome to part 4 of these practice problems under set operation in mathematics. And in today's video, we're going to be looking at question number 6. And this question number 6 goes this way. It says, let U, which is the universal set, be equal to this set of numbers ranging from 2 serially down to 11. And set A, this equal to this, which is 3, 5, 7, 9, and 11. Finally, set B rather says it is set of numbers ranging from 7 down to 11. And now we are asked to use this information to answer the following questions, which is these questions you see, ranging from I to V. So I, IV, and V. So without wasting time, let's just get into solving it. We've seen something similar, something like this in the previous question we solved. Okay, so let's start with the first one, which says A minus B. And the good thing here is that all the sets here are all given in listing method. So there's no much problem here. And it would have been a problem if we would have, or maybe if we had given this set in a set builder notation. So since we are given the set in the listing method, so it's just very easy for us to tackle. So A minus B in this case is, this is A, this is B, this is set A, this is set B. All right, so A minus B will be, take what both of them have in common and write only the elements in the first set mentioned, which in this case set A. So what do you think these two sets have in common? They do not have A3 in common, they don't have 5 in common, they have 7 in common, so 7 is going to go away. They have 9 in common, they also have 11 in common. Very, very important. So A minus B is nothing but 3 and 5. 3, 5. Okay, so that is it for I part of. So the answer is going to, the answer for I is nothing but 3, 5. Very important. Okay, let's get into the second one. Now, second one is A minus B complement. That is, this A minus B now, A minus B complement. Now, this A minus B, look at it here. Therefore, A minus B complement will actually be what? Now, it's more like complement of this set, 3 and 5. Now, whenever you are given a set and you are asked to find the complement of that set, it will mean what is it? What are the set? Or maybe write out the set in the universal set that is not in the given set. So the set of number in this place now that is not in this given set is nothing but 2, 4, 6 down to 11. So 3 is already in the given set and 5 is already in the given set. So these 3 and 5 are already in the given set. So I'm going to write out every other number in this universal set minus 3 and 5. Therefore, I'm going to have 2, 4, then 6, 7, 8, 9, 10, 11. All right. So the II part of the equation is nothing but 2, 4, 6, 8, no, 6, 7 rather, 6, 7, 8, 9, 10, 11. All right, so this is it for II part of the equation. So please do well to take the notes. All right, now the III part of the equation says universal sets. All right, the universal set has this kind of symbol. So universal set minus A minus B complement. So for us to tackle this problem, that is what the third part of the equation is talking about. So we should find this. All right. So first, let us look for A minus B first. Before we can tackle this problem very effectively, let's look for A minus B. All right, which is the relative complement between A and B. And this is set A, this is set B. So A minus B will be, take both of them have in common and leave only. So of course, A minus B, we've already gotten it to be 3 and 5. All right, and the complement of A minus B now is nothing but this, which is A minus B complement is equal to this same thing, which is nothing but 2, 4, 6, 7, 8, 9, 10, 11. All right, and finally, to now look for this, finally, the universal set minus the whole of this. Universal set minus A minus B complement is what? Okay, so only A minus B complement is already this. Therefore, the universal set minus the whole of this, which is something as this, will now be, that means we are relating this now with the universal set. So it will be, take out what this set and this set, take out what both of them have in common and leave the answer that is in the universal set. Okay, so what do you think these two sets have in common? If you look on the two sets, they have 2 in common. They don't have 3 in common. They have 4 in common. They don't have 5 in common. They have 6 in common. They have 7 in common. They have 8 in common. They have 9 in common. They have 10 and 11 in common. Therefore, the only set that they do not have in common is something about 3 and 5. All right. So this is something about 3 and 5. Very, very important. Okay, so we now have that I part of the equation is nothing but 3, 5. Okay, please do well to take down the notes. All right. So let me just clean this part. Now, next thing to be done here is, let us look for the IV part of the equation. So IV says that A union B all complement. First, let us look for A union B before taking the complement of these two sets. Don't forget what union of two sets means. That is, these two sets, write out all the elements both of them have together. Write out all the elements in these two sets, but do not repeat anyone that occur twice. Very important. So if you watch carefully now, so we are going to start from 3, 5, 7. So we have 3, 5, 7, 8. So 3, 5, 7, which is also here, 8, 9, 10, 11, and that will be all. So this is nothing but A union B. So 3, 5, 7, 8, 9, 10, 11. So of course, if you watch carefully, 11 occur twice. So I'm going to write just one 11. 9 occur twice. 7 occur twice. So all those ones that occur twice, I'm just going to write them once. All right. So in summary again, the union of two sets is nothing but write out all the elements in the two sets you're taking their union, and please do not write or do not repeat any element that occur twice. Very important. Therefore, A union B complement will now be what? So this set of number now, what are the elements inside here, but they are not inside here? So let's quickly write them out. That will be A union B complement. So if you watch carefully, they have 3 in common, they have 5 in common, they have 7 in common, they have 8, they have 9, they have 10, they have 11. So the only elements that are here but are not here are 2, 4, and 6. So 2, 4, and 6. Therefore, IV is nothing but 2, 4, 6. All right, so that is it for the IV part of the question, 2, 4, 6. Now, finally, V part of the question says A complement union B complement all complement. This is very, very funny, or I love this kind of question. So in this case now, we're going to first look for A complement, look for B complement, take their union, then that union again will also take the complement. But let me even clean this. Let me make sure that I can have space to solve it up. So please do what to take the notes. It's very, very important. So finally, we say that this last one is A complement union B complement all complement. First, A complement is what? Remember how we used to take our complement. We are going to be taking complement of a set with respect to the universal set given to us. Therefore, set A is already this. So the complement of this set A will be the elements that are in the universal set that are not in the given set A. So the elements, these two sets, they have 3, they have 5, they have 7, they have 9, they have 11. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So therefore, A complement is nothing but 2, 4, 2, 4, 6, 8, 6, 8, 10. So A complement is more like set of even numbers, 2, 4, 6, 8, 10. What about B complement? Now, B complement again is going to be the elements that are in the universal set, but they are not in the given set B. So they have 7 in common, they have 8 in common, they have 9 in common, they have 10 in common, they have 11 in common. So B complement is nothing but 2, 3, 2, 3, 4, 2, 3, 4, 5, 6. All right. So set of B complement is nothing but set of natural numbers ranging from 2, then stopping at 6. Very, very important. So now we've gotten A complement and B complement. We're going to take the union of these two sets. Therefore, A complement union B complement is nothing but, again, writing out all the elements in these two sets without repeating any one that occurred twice. So they have 2, they have 2, 2, so I have 2. They have 4, 4, I have 4 just once. But first, before I write 4, I think I need to write 3 first. Yes. Okay, so I now have 4. I have 5. I have 6. There is no 7 here, so I will now have 8. There is no 9. I will have 10. And of course, there is no 11. Okay, so it is actually 2, 3, 4, 5, 6, 8. 2, 3, 4, 5, 6, 8, 10. So this is the union of these two sets. Now, but don't forget, that's not the answer. This is actually not the answer to this. Now we've gotten the union of, this is the answer to the union of these two sets. But we are asked to get the complement of this. Now we are going to get the complement of this set of numbers. Therefore, A complement union B complement or complement is now equal to what? So we are going to now relate it to the universal set again. So what are the numbers that are here but they are not? What are the numbers that are here actually but they are not here? So we're going to write out all those numbers that are in here but they are not here. And those numbers are going to be, of course, let's take what both of them have in common. Let's take it out. So they have 2 in common, they have 3 in common, they have 4 in common, they have 5 in common, they have 6 in common, they don't have 7, they have 8, they have 10. So the numbers they don't have in common here is 7, 9, 11. 7, 9, 11. Alright, so therefore the V part of the question is nothing but 7, 9, 11. Okay, so please do well to take down the notes. It is very, very important. So see you in the next part of this video. So this video will just attempt to talk about question number 6. So this is just the answer. So you can rewind the video as many times as you can to ensure that you've learned it very, very well. So thank you. Please, like I always say, do well to subscribe to our YouTube channel, comment, like, share. God bless you.